Scientists have stumbled upon a mysterious object floating out in space. They're not entirely sure if it's a star or a planet. The only thing certain is that it lies 1,400 light-years away. This discovery challenges what we thought we knew about the universe. Let me break it down and explain the confusion in this case. We usually classify objects as stars or planets based on their mass. Stars are extremely massive, which gives them intense gravitational force within. This gravitational squeezing leads to high internal temperatures, making stars shine brightly. On the other hand, planets have less mass and weaker gravitational pulls. They don't undergo the same extreme internal processes as stars typically do. Instead, planets shine by reflecting light from their nearby host stars. Think of Earth reflecting the sun's light, creating our beautiful daytime glow. Now, this object falls somewhere between these definitions, complicating its classification greatly. Astronomers have labeled it a brown dwarf, a kind of failed proto-star. Brown dwarfs have atmospheres similar to Jupiter, yet are significantly larger in size. These objects range between 13 to 80 times Jupiter's mass astronomically speaking. Once a brown dwarf exceeds 80 Jupiter masses, it ignites regular hydrogen. This process is what usually makes stars shine so brightly in space. However, most brown dwarfs aren't hot enough for sustained hydrogen fusion. That's why they've earned the nickname failed stars in the cosmic community. Brown dwarfs typically burn at around 4,000 degrees Fahrenheit, much cooler than most stars. But here's where this discovery gets fascinating: it burns at 13,900 degrees Fahrenheit instead. To put that into perspective, consider Earth's hottest recorded temperature ever. Death Valley, California, reached 134 degrees Fahrenheit over 100 years ago. Inhabitants felt like melting. Imagine venturing closer to the Sun. Venus regularly experiences 860 degrees Fahrenheit temperatures. Despite being farther from the Sun, Venus traps heat due to its atmosphere. Mercury is closer, but Venus's greenhouse effect makes it dramatically hotter overall. This peculiar brown dwarf's extraordinary heat has an intriguing explanation behind it. It's situated remarkably close to another star, classified as a white dwarf. The two objects orbit each other so closely, in just 2.3 hours. Such proximity causes tidal locking, much like how our moon faces Earth. One side of the brown dwarf remains perpetually exposed to the white dwarf. This constant exposure superheats one side while the other remains icy cold. These extreme conditions cause the atmosphere's molecules to disintegrate into single atoms. This fascinating phenomenon indicates the object is slowly fading and disappearing over time. But if you think this brown dwarf is hot, wait until Eta Carinae. Eta Carinae is a star system located 7,500 light-years away from us. It belongs to a unique class of stars known as luminous blue variables. It was first observed in the 17th century as a medium bright star. However, nearly 200 years later, astronomers saw it explode with dramatic brightness. This eruption was dubbed the Great Eruption, making Eta one of the brightest stars. For years, it shone brightly, rivaling supernova explosions, before finally dimming again. The Great Eruption expelled vast gas and dust, forming a surrounding nebula. This nebula now obscures some of Eta Carinae's light, creating an ethereal glow. Eta Carinae is a binary system with two stars orbiting one another. One of these stars burns at about 26,500 degrees Fahrenheit, while the other reaches 62,500 degrees Fahrenheit. The larger star is 100 times the mass of our Sun, absolutely colossal. Its massive size ensures it will one day explode into a spectacular supernova. However, that event isn't expected for thousands of years, so don't worry. Supernovas occur when massive stars exhaust their fuel and can't resist gravity. Their cores collapse, leading to unimaginably powerful explosions that release immense energy. The last major supernova observed from Earth was Kepler's supernova, centuries ago. We did see a smaller one in 1987, from a blue supergiant. That event occurred in the Large Magellanic Cloud, 168,000 light-years away. The explosion was visible to the naked eye, a rare and stunning sight. But even human technology has achieved extreme temperatures that rival celestial phenomena. In Switzerland, scientists created a quark-gluon plasma, recreating post-Big Bang conditions experimentally. This plasma reached temperatures 250,000 times hotter than the Sun's core, mind-blowing. And theoretically, the Planck temperature exceeds even these extremes, unimaginable in cosmic terms. Supernovas, plasma, and mysterious brown dwarfs all remind us of space's endless wonders. Explore, learn, and share these incredible stories to uncover the universe's secrets.